Hello, students. Nice to see you again. Okay, today I will start teaching you chapter 1, which is basic knowledge in physics. Okay, the first topic that I will teach you is quantity. Okay, in physics, or actually in science, physics, sorry, in physics or in science, quantity, we can separate the type of quantity into two main types. The first type is called scalar quantity. The second type is vector quantity. And how different between scalar and vector quantities? I think that most of you know already, but I will tell you again. Okay, here, scalar quantity is the quantity that needs only magnitude. What does it mean, needs only magnitude? It means that uh, that quantity, when we set the value of that quantity, follow with the unit, we all understand. We don't need to tell the direction. For example, when we say that the temperature in this room is 25 degrees Celsius, okay, we know that the temperature about 25 degrees Celsius is cool enough for us. It's not too cool or it's not too hot, okay? Or if we said that, if I ask you how tall are you, if you said that you are tall, your height is about 1.5 meter, okay, 1.5 meter, 1.6 meter, or 160 centimeters, we can imagine how tall we are, okay? It means that the height or the temperature are kind of scalar quantity, because these two kinds of quantity don't need the direction. They just tell the size or the amount of that quantity. It's just enough. Okay, so here, can you give me the examples of scalar quantity? I think that most of you know, but someone forget already. Okay, I will not say anymore. I will tell you. Okay, the the example of scalar quantities are scalar quantity. This are example. Okay, the first one is mass. Okay, mass. Most students think that weight is scalar quantity, but actually not just mass, but mass related to weight. Okay, the next one that I just raised as an example for you, it is temperature. The next is about the height. Actually, height or range is kind of quantity that we usually mention about distance. Okay, so I will use distance. Okay, actually distance, range, height has the same unit. Okay, distance divided by time is speed. So speed is a kind of scalar quantity. Next that I would like you to know is work, okay, power and energy. Okay, here are examples of scalar quantity. Actually, another can be scalar quantity, for example, volume, density, but it will not like for you. If you would like to take notes, you can write by yourself. Next is vector quantity. Vector quantity is the quantity that needs both magnitude and direction. So when we mention the magnitude, we have to mention the direction as well. Okay, example of vector quantities are force. Actually, all kind of force, vector quantity. So I will list this as one example of vector quantity weight, because weight is a kind of force. Okay, weight is not scalar quantity, but it is vector quantity because weight is force that Earth exerts to the object in downward direction. So the direction of weight is always down to the center of Earth. Another example of vector quantity is displacement. Okay, it's similar to distance but not the same. Similar but not the same. Next is velocity. Velocity also similar to speed but not the same. Okay, another one is acceleration. Okay, next is moment and momentum that I would like you to know. Actually, momentum you will study in M4 if you further study in math science. Okay, now I think that you can identify difference between scalar and vector quantity already. Next is about the unit of some quantity. Actually, we have many types of unit, but here we will talk about just only SI unit. Okay, just only SI unit. And for SI unit, we also can classify into two types. The first type is basic unit and derived units, derived quantity. Basic units, actually it can be basic quantity. The basic unit is the unit that do not derive from any other units. They are the base, okay? They are the base of other units. Here we have only 7 basic quantities that have their basic units in SI unit. Okay, let's see here what are these 7 quantities that do not derive, their unit do not derive from any other units. Um, let's see the first one, length. The length unit, SI unit of length is called meter. Okay, meter. Symbol of meter, we write it as small letter M. Don't write capital M. It's incorrect. Okay, it must be small letter M. Mass unit is kilogram. Symbol of kilogram, we also use small letter kg. Time unit is second. Okay, second. And symbol is small letter s. Current unit of current is ampere. Okay, if you recognize here, you will see that I write A here as the capital letter, and its symbol unit of ampere we use capital A. Why do we use capital A? Because this is from the name of a person. When we use the name of a person as a unit, we have to use capital letter. Okay. Next is unit. The next quantity, base quantity is temperature. And basic unit or SI unit of temperature is we use Kelvin. Okay, Kelvin. And the symbol of Kelvin, we use letter K. Okay, letter K. Also use capital K because this is the name of a person. Luminous intensity. Luminous intensity. Actually, for the other, I will not tell you in Thai, but luminous intensity in Thai we call ความเข้มแห่งการส่องสว่าง Okay ความเข้มแห่งการส่องสว่าง Unit of luminous intensity is we call candela. Okay, candela. And the symbol of candela we use letter C and D. C follow with D. Amount of substance in Thai we call ปริมาณเนื้อสาร Amount of substance unit is mole. Okay, mole. And the symbol of mole we write it similar to the full unit. Just cut the letter E. MOL is the symbol of unit that is called mole. Okay, now you know the 7 basic quantity that have their own basic unit. Okay, they are range, mass, time, current, temperature, luminous intensity, amount of substance. I hope you can remember. Okay, what about the next type of quantity that have their units? And the units from this derived quantity are derived from these 7 quantity. For example, here are just the examples, okay? Actually, we have another quantity rather than this that I show you. Just would like to list as example for you. Okay, the first example of derived quantity is area. Okay, you know that area. Actually, if we would like to know an area of a rectangle, for example, suppose we have a rectangle, okay, this rectangle, we would like to know how much is the area of this rectangle. We just measure length of this side and this side, right? This side actually we call width and length. So the area of any square or rectangle we can calculate by using this equation. It's equal to width multiplied with length, and width and length we measure in unit as meter. So the unit of area is the unit of width follow with unit of length. Unit of width we measure in meter. Okay, follow with meter or meter times meter that we call meter square. Okay, so this is the symbol, unit symbol of area. We call meter square. Volume of, suppose we have a cubic and we would like to know the volume of this cubic. We just measure width, length, and height. So we can calculate the volume of this cubic by multiply the width multiplied with length and height. Okay, these three sites that we call width, length, and height, they are all measured in meter. So unit, basic unit, basic unit of the volume is unit of meter, follow with meter, or we means that meter multiply with meter, or meter cube. Okay, meter cube. Okay, next, density of any object. I think that most of you already know that if we would like to know density of any object, we just multiply two quantity together. Sorry, not multiply, divide. Density of any object will equal to mass of that object divided by its volume. Okay, as we know from the previous topic that unit of mass we measure in kilogram, or basic unit of mass is kilogram. We divide by volume, so unit of density will be the unit of mass slash unit of volume. Okay, because it's equal to mass divided by volume, so we use this symbol. We call slash. Unit of volume we just got here that we call meter cube, so we will divide by meter cube or unit of volume. Okay, what about velocity? Velocity, if you studied previously, I think that you may be remember that velocity is from displacement. Actually, it is from sorry, I have to use this one. Displacement. Unit of velocity is the unit of displacement divided by divided by time. So unit of velocity is unit of displacement per unit of time. Displacement unit is meter and slash unit of time, which is second. So unit of velocity is meter per second. Okay, next, acceleration. Acceleration is equal to velocity change divided by time. I will teach you again in the next chapter when you study the topic of acceleration. But here, I would like you to know first that acceleration is equal to velocity change divided by time. Okay, and unit symbol, unit of acceleration is unit of velocity, which is meter per second. We divide by time, so we have to slash time again. Okay, be careful about this symbol. Actually, we mostly write the unit of acceleration as meter per second square because it divides by second twice. Okay, the next example of force, example of derived quantity, which is force. If you study Newton's second law, you will know that sigma F equal to ma. So it means that force It's equal to mass multiplied with acceleration. Okay, force equal to mass multiplied with acceleration. So unit of force is unit of mass, which is kilogram, follow with unit of acceleration that we just got from the previous one. Okay, so unit of force is kilogram meter per second square. But most of you know already that unit of force we usually call just Newton. But you have to know that this Newton comes from this basic. Okay, kilogram meter per second square equal to Newton. And here in the blanket is the symbol. Okay, work if you study further. Oh no, actually, for last year, student M3 will study work in semester 2. But I think that for you who are M3 in this year, you have to study work last year already. So you must know that work W equal to Fs. So work it's equal to force multiplied with displacement. Okay, work multiplied with displacement. Unit of work is unit of force followed with unit of displacement. Force we already know from this previous that it is Newton. Follow with displacement. Displacement has the same unit as distance, which is meter. Okay, here is the unit of work we call Newton meter, but we mostly use Joule. Joule is the name of a scientist who create this equation. Okay, here we finish the first page that is about the quantity and unit already.